In this video, we'll be learning how to find the volume under a function using the shell method. The shell method is a way to find the volume of a function rotated around an axis or a line using cylinders of different sizes. The shells are sort of like Russian nesting dolls. They each get infinitely thinner and fill the area or the volume underneath the curve. By calculating the volume of each cylinder added together, you're actually finding the total volume underneath.
The general formula for the shell method is when volume equals the integral of the surface area of the cylinder, which is the integral of 2 pi times the radius times the height dx.
You use the shell method when you have horizontal cross-sections rotated around a horizontal axis, or when you have vertical cross-sections rotated around a vertical axis.
This is an example of a function where you need the shell method because the area is rotated around the y-axis, which is vertical, and the cross-sections are also vertical.
The first example we're going to do is with a calculator. If you don't know where to begin, first find the different pieces you'll need. Set up your formula and find the radius of the shells you'll be using. Also find the heights and plug those in to begin. The radius of each shell in this case is the x value because the radius will be horizontal. The shell height will be the y value, or the f of x value. In this case, it will be root x, and that goes in the shell slot. After plugging our integral into the calculator, you get an answer of 128 pi over 5. Is that what you got?
The next example is without a calculator. We have the equation y equals 3 minus x revolved about the x-axis, and x is greater than or equal to 0, but less than or equal to 3. We're going to begin where the function is parallel to the axis of the revolution. We're going to write the equation in terms of y and solve for x. So g of y equals 3 minus y. Then we're going to find the antiderivative and the volume by doing the equation 2 pi over the integral of 0 to 3 of y times, open parentheses, 3 minus y, close parentheses, dy. And we're going to plug in the upper and lower limits. Now to solve, we're going to take the equation x equals 3 minus y and plug it into the volume equation. So we have the volume equals the integral of 2 pi rh dy. So plugging it in will look like v equals 2 pi over the integral of 0 to 3 y times 3 minus y dy. And we're going to take out the 2 pi and put it on the outside of the integral. Then we're going to find the antiderivative of y times 3 minus y, which turns out to be 3 halves y squared minus 1/3 y cubed. Then we're going to plug in the upper and lower limits, and we'll get 27 over 2 minus 9. And now we're going to multiply both of those terms by 2 pi, which ends up being 27 pi minus 18 pi. And after subtracting, the final volume is 9 pi.